Hello, everyone, and welcome to the Incubator Podcast. I'm your co-host, Darren Boyd.
And this is Sabir Sran. We are excited today to continue our focus around application security with Gartner's leading vendor in the application security testing space, which is Synopsys. Really excited to have Synopsys here, leading the past. You want to interrupt me again?
Yeah.
Yes.
So here's one thing I want to talk about with Synopsys before, and I'll hand it back, I promise. So started in the EDA space, right, with silicone design and verification, silicone intellectual property, back in '86, right, RTP. But then I believe, and we're bring our guest on to validate what I'm going to say here. Since 2014, they formalized some of their products and services around application security testing. So I think what you were about to say was for the last 6 years, they've been the leader, but they've only been formally in the space for 8. So like that's a phenomenal marker of success.
It is.
And not just a leader, I'll say the leader in application security testing. All right, that was it. Sorry, back to you.
All right, so we have Tim Mackay, who is the principal strategist at Synopsys. And Tim, would you mind giving us a little bit of an intro background of yourself, and then we'll get into it?
Sure thing. So I have the glorious title of Principal Security Strategist, which means I get to play with an awful lot of stuff, an awful lot of tech, and kind of have my fingers in a whole bunch of things around, not just here's a new technique to go figure something out, but why you would want to use it. What's the real problem that someone's trying to solve? Where are they going and where are they coming from, which is kind of cool. So I've been in open source for dog's years. I was community manager for a few years. I've been working with containers since before Docker was a thing. I've been working with virtual machines since before EC2 was a thing. So I've got a pretty broad container cloud security background. Distributed systems engineering is where I cut my teeth, where if stuff fails, bad things happen, like you end up with an oil spill and you have to involve the EPA and stuff like that. So my whole mindset is around, okay, so how do we make these things bigger, better, stronger, but in a scalable way?
Well, we're clearly talking to the right person. That's what we strive for here in terms of Incubator and bringing a practitioner's view of people who have lived through all of this. And as you mentioned, Tim, that's a pretty impressive depth of field that you have. So coming to our topic du jour today, we wanted to get into application into the AppSec space as a whole. Synopsys has a whole portfolio offering, and when we double click into application security testing, we're really talking about SAST, DAST, IAST, and getting into SEA and software composition analysis. Would you help us, Tim, break down maybe each of those areas? We'll take a pause in between as you go from SAST to otherwise, just to exchange a little bit more so we can orient around this and then understand the whole domain.
Yeah, sure. The way I like to look at it is everyone has a certain set of responsibilities. And so SAST, or static application testing, that's really, really geared towards the code that you write, the code that is unique in your organization, the code that is going to drive true value for the business. SCA, software composition analysis, that's really worrying about stuff that other people write that comes into your organization. That's helping you understand, for example, is a software library, whether it's open source, which is the traditional definition of software composition analysis, or just a commercial third-party library, whether that's something that maybe has an unpatched vulnerability associated with it, or it's getting a little bit long in the tooth and you need to upgrade it and get a newer version. That's all the province of software composition analysis. That's partly a decision made by a team to say, I want to use this library to do this thing, but it's worrying about the other people's code. Mm-hmm. DAST kind of gives the umbrella of, okay, so what might this look like in a running environment? But that also gets us into a little bit of a flavor of DAST known as IAST, which is really, what does it actually behave like as it's running? So DAST is looking at the set of external inputs that you can provide to the thing as a system, when there might be firewalls that are providing mitigation to certain types of threats. They're going to look at the entire black box of it all. It's almost like a pen test to a certain degree. And then IAST is saying, well, as I'm running, what bad things could be happening that maybe are blocked at the edge?
Mm-hmm. Yeah, and if we look around the industry, there's folks that have decided to specialize as companies. Now, every one of those categories. You're a leader in the space, but you're a leader in the space in all of those individual categories. Can you talk about maybe that portfolio approach and why no one else necessarily has the breadth of products that Synopsys has been working on? You're only 8 years into this, and this is a phenomenal amount of research and innovation that's gone into this product set. Can you talk us a little bit about that and how you're maintaining that leadership position?
So that's a hugely important question. Now, truth be told, we haven't been at it for 8 years. We've grown through a combination of acquisition and innovation. And myself, I came by way of the Black Duck acquisition in 2017. Black Duck's now just about 18 years old. So we had a little bit of a party last year. And we said, now we can vote. It's one of these things where the technologies have had their teeth cut to the point where they've become recognized in the industry as a true leader. So, for example, in the M&A space, Black Duck has now become an adjective or a verb. You get Black Duck before you get acquired. There's a whole process to go through and see what the technical due diligence is, and we pioneered all of that stuff dozen plus years ago. So it was a natural thing for Synopsys as it's building up the portfolio, which is a really huge portfolio, to go and say, yeah, you know what, software composition analysis, we want the big duck. Let's see what we can do to get the big duck. The same thing with static analysis. When we formed the software integrity group, that was through an acquisition of a company called Coverity, still the name of the product. And so we tend to keep that kind of brand identity as we move along, because people understand Black Duck means this. Black Duck is really good at that. And of course, post-acquisition, for me, the acquisition of Black Duck was close to 6 years ago, and we're still going strong. Majority of people from that acquisition are still happily part of Synopsys, happily doing the right things when it comes to software composition analysis and innovating accordingly. And so that's true with all of the various teams that we have. But it's not just about being strong in a silo. It actually requires us to understand what it means to have like the whole end-to-end view of what an application security set of requirements are, from the developer's experience all the way through to the security teams and the operations teams, because they've all got different requirements. Some of it can be accomplished with the same tooling, but if you try and do the whole square peg round hole thing, it doesn't always work out very well. And we're in the enviable position of being able to say, okay, so what's the problem that you want to solve? Yes, we have a solution for that. We don't have to worry about all the other problems and try and do some kind of unnatural sales act to solve a problem. It's just, yeah, we can solve this way. This is how we do it, and walk in as recognized experts.
Yeah. So that's a pretty compelling offering that Synopsys has. I would say it feels like a very, or maybe the most complete portfolio in the application security testing space that you've just highlighted. And you also said something very interesting is about the developer experience. So everything these days is about the developer experience. So how is Synopsys, or your view, Tim, where certain organizations or enterprises are today in terms of their maturity with AppSec testing or programs that are helping the developer or the DevSecOps lifecycle? You know, where are folks today in that whole journey?
Well, one of the things, and this is a pitfall that I talk about quite a bit, is that there's no developer. Everybody loves to say, hey, I'm going to shift left, and there's some mythical, magical developer who's going to save the world for all of the ailments that might be within the software, for all of the functional people. No, there is no single developer. There's no magical developer who knows all that there is to know, privacy, regulatory, what have you. Making everything kind of come together in a nice, neat package requires context. And so when the developer, a proverbial developer, is working on a ticket, whether that ticket is new feature, whether it's a burn down of existing technical debt, whether it is addressing a simple bug, that context is really, really important to the developer who's working on that particular problem. And so if we can, from an AppSec perspective, give them exactly the information that they need to solve the problem inside the IDE as the software is being written. Now we're not forcing them to go out to another console. We're not forcing them to learn another product. We're just saying, hey, the moral equivalent of spell check, there's a red squiggly line underneath something. I should go take a look at this and find out why there's a red squiggly line under this thing. And maybe it's a case of that particular piece of code, well, you called it to open a something, but you forgot to close the something. Mm-hmm. And that's going to cause a leak. And here's what a leak is. Maybe they don't understand the sequence of activities. Here's some online training that will go and be contextual to that particular problem, so they can go and say, well, what did I need to do? What did I do wrong? Because nobody's an expert in every language. Nobody's an expert in every possible framework. Stuff happens. We're all human. So if I can just give you the stuff, the information that you need in context, then AppSec isn't a scary thing anymore. It's now an aid as opposed to an impediment. It's not slowing down feature velocity. It's actually making certain that you don't end up with any rework and everybody wins.
A quick follow-up on that. Sorry, Darren. You mentioned the IDE. So are particular modules more applicable within the IDE versus things that are rolled out to production, therefore post-deployment?
So it really becomes kind of a continuum. Mm-hmm. So if I can give you the information in your IDE, well, that's one developer's view of the world. They're still going to need to make a commit. That's still going to need to be merged in with all of the other activity that is happening within the development team, which then means that there's a possibility for a conflict between two developers who are working in close to the same code. They might stomp on each other just a little bit. That's never happened before in the whole history of software. So you want to have a series of tests that occur that are understanding the combined change set in order to actually say, yes, this can move forward into the pipeline. That's a little bit more of an impediment because there's additional testing that occurs in a pipeline. It's a little bit slower. So one of the things that we see a lot more of is the use of technologies like IAST. So the Synopsys product is called Seeker there, which can run in parallel to all of the functional and non-functional testing that's already occurring. So you get some of the benefits of static analysis, all of the benefits of the interactive analysis, without incurring an additional duration of testing while you're running all of your gated tests. And that becomes a low friction way to go and say, how do I actually bring all of the security testing in that I can that will be developer related without actually slowing people down?
So there's and one, I'm going to have to apologize because we're going to bounce around a little bit. You guys do so much that there may not be a ton of cohesion, but what I was thinking when you were talking about that is, so I started thinking about a customer we have. It's a healthcare company, and they do all COTS, right? So some of this isn't necessarily a primary concern. However, with the FTC coming down on folks with their full legal authority on reasonably addressing Log4j vulnerabilities, and with Biden's executive orders on how we're going to interact with the government when it comes to things like SCA, one of the concerns that this healthcare company had was, hey, if we're all COTS, what is the implications of software composition analysis and vulnerabilities, dependencies, software bill of materials, et cetera, at a commercial level that could cascade down to us? And what should we do to safeguard? Is that, like, they've already committed to some vulnerability programs where they'll prefer vendors that have transparency programs and various, I'll just call them measures that they're exercising internally. But invariably, I'm now consuming your software. That liability may pass down to us. They recognize that sometimes they have identification challenges. So in the context of somebody that's COTS, what kinds of things can they start to implement to safeguard and protect themselves from some of these cascading liabilities?
So one of the most effective ways is to implement a process around trust but verify. So you trust your COTS vendor. You trust, and you've done all of the vendor risk management on them. You know everything that's possible to know about them as a vendor. What you're lacking is visibility into what each individual software release is and what each individual binary's role in the solution might be. So from an SCA perspective, if you now just, let's assume that they're all binaries, that there's nothing that's running in an interpreted manner. If you've got a binary, you can put it through a binary analysis solution that is SCA focused. It'll generate the same bill of materials that a regular source analysis would. And now you can go and say, here are the elements and versions of the components that are actually powering this particular application. Every year at Synopsys, we put out a report called the OSRA, the Open Source Security and Risk Analysis Report. And that looks specifically at commercial software in the M&A transaction world, but looks specifically at commercial software to see what open source usage is in a variety of industries and breakdowns based on all of the engagements that we have during the year. Consistently, over the last 4 years, we've seen over 70% of the code is actually open source in nature. So it's not a case of saying, hey, I have this proprietary code, I put a box around my 4 walls of my organization and there's no external dependencies. That's technically never been true. You always had a compiler from somebody, and those were always libraries that were coming in. That's still software supply chain. So if you can get visibility into this particular application is using or dependent upon these components, now you can have a conversation with the supplier and say, okay, so in the context of Log4j, I see that you have Log4j inside of these applications, but not inside of those ones. What's the current plan and release timeline that you have? And what are the mitigations that I should be thinking of putting in place while you author that patch? Yeah, and then, of course, as Log4j kind of evolved, it was like, okay, well, you got the 2.14 patch in place. Lovely. 2.15, that's a bit of a problem. We see that you got that in there. What's your plan for that one? And as the patch flurry went out, you can have a further conversation. And basically, it starts to have a team spirit that gets created between vendor and consumer.
So I do want to pick on that OSFR report, not pick on it. I want to highlight some things because what you said is one interesting stat. And I saw what you've put out recently. There's a lot of other interesting stats in there. Like it said, the 22
waiting for this.
Yeah. The 2022 report said 97% of all of the commercial code base that you scanned contains open source. And then
at least one component.
At least one component. And then 78% of that code base was open source. And then it just gets frightening from there. Like we're talking about like over 2 years of non-development. I think that was in the high 80s or something. And it's
so yeah, that's actually been consistently true. And Log4j actually gives a little bit of insight into that. So everyone who went through the whole Log4j experience and said, oh, well, I'm going to patch my Log4j version 2, my 2.13.3, my 2.14.0, my 2.14.1, suddenly as they were going and looking at their systems, found that there was an awful lot of Log4j 1.2.17, and they couldn't understand exactly why. That thing had an explicit end of life statement back in 2015. It had no new development since 2012 or middle of 2012, something like that. And so that's a perfect example of legacy code where the whole mechanism around end of life statements and security updates is very, very different than commercial software. Commercial software, the vendor knows their customers. They've got some transactional relationship where they can go and say, these people are using my stuff. In open source, you don't. Freely downloadable means I don't know who you are. So the responsibility of keeping up to date with new patches, new releases, new security disclosures, and so forth is purely on the consumer who needs a solution like an SCA solution. Otherwise, you get out of date very quickly. So that's scenario number one. And scenario number two is applications have a pretty long life cycle, but all the foundational decisions, they're made early on, and they're so deep in the bowels of the application that you may not necessarily know that you have exposure to a whole class of problems because you're not thinking about, oh, wait a minute, my Node.js application probably has a whole lot of jQuery in there someplace. And nobody's worrying about jQuery because I'm not deciding that I'm using jQuery.
Yeah, 2 questions on that, Tim. So for the open source software that's been out there for ages, and well, it's a known vulnerability as as the scan would identify. What if there's no known patches for that because that whoever produced that open source software is decided not to update that? How does an organization manage or deal with that?
So effectively, and the scenario that I use is that, hey, the core development team consists of, say, 3, 4, 5 people, and they all collectively went on and bought a Powerball ticket, and man, they were lucky. They might not want to go and work on software anymore. They might want to, say, go buy islands and spend time golfing, hanging out with the kids, just
again, that sounds like Darren.
Software, yeah, not software things, at least for a while. And so that now becomes code that is quote unquote done, warts and all. So when you find that you have code that is in that particular category, that's now code that you own, that you have responsibility for, and that you should be treating as if it was custom in-house proprietary code and are testing it accordingly. Because there's one truism in a software supply chain. Your suppliers do not follow the same security standards and have the same security targets that you do. Your supply chain does not know that, for example, you're a HIPAA regulated entity, or you have PCI compliance, or any of the other regulatory requirements that we might have, either in the US or globally. They're just writing software. And if all of a sudden there's a change in the definition of PII and an email address is now something that should never be put into a log file, that's kind of the consumer's problem to know that they're subject to that PII requirement and that their software shouldn't be putting email addresses into log files or something similar.
So one other question I have here, I'm genuinely curious. I don't know how this works, and I don't know if you can address it, but the other reality is license misuse. We've seen quite a few different license types in FOSS, and I'm genuinely curious, what happens if a commercial product is in violation of some license, and then I buy that as an end customer and I'm using it? Does that liability potentially cascade down to me as a consumer, that I may have to now address the fact that there is a license misuse and there is a concern there?
So you, Darren, as a human, go and buy something from, say, Amazon. Yep. You're using it in your house. Your concern is, do you have liability if there's a license compliance? Is that the question?
That is. I'm just curious.
Okay. So you don't.
Okay.
The compliance issues are squarely on the individual or organization that released the software. So effectively, all of the license compliance issues are triggered whenever a distribution occurs. So you could put the software up on a website and have the same issue as to whether it's baked into a product that you go and buy from Amazon. The core challenge from a license compliance perspective is that you can have licenses that are mutually incompatible. And the canonical example is you have a reciprocal license that says you must always release your source code. That is now a component of something that has a permissive license that says you don't have to release your source code. How do you reconcile that scenario? And there are ways of doing it. And ultimately, we don't hear a lot in the news about license compliance issues the way that we did, say, 10 years ago. And that's because, for practical purposes, businesses have gotten a little bit smarter about how they address the deficiency, and are willing to say, okay, so this was the box that we got ourselves into. We're going to do diligence before we buy the asset. We now know what the warts look like, and here's how we're going to approach it. We may have to go and bring some people on board to effectively fork that code and leave that version out there, but we're going to move forward with this. We may find a substitute component. We're still stuck with the obligations for this, but we're going to fix it and, quote, cure it as we move forward.
Yeah. Okay.
And so it's definitely one of these things where, as greater awareness of open source and open source management and governance enters the commercial world, these things are solvable problems. They always were solvable problems, but people tended to get a little bit pricklier, say, a decade ago. Now they just say, okay, this is part of what I need to do. Now I know what the problem is. I have a process I can follow, and things happen.
Well, that's good. As long as I don't have to pay, I guess really.
You're good. Unless, of course, you take that software, you modify it, and then you ship it. Now the onus is on you.
Yeah. Yeah. All right. So really the conflict then is, hey, that company may have to divert resources and attention, but at least it doesn't pass through to me.
The best example of business impact is when Cisco bought Linksys and had to basically open the whole system up.
Okay. Okay. Now, I think this may be a great segue, because OSFRA was influenced by the Cybersecurity Research Center and a lot of the work that's happening under there. Can you walk us through what your role is? I know you said you get to play with things, you get to really see how it impacts the world, but what is happening in the Cybersecurity Research Center that you can share with us?
So we fundamentally have a couple of things that are ongoing. Our primary charter is to do large reports like the OSRA report, do specific research around vulnerabilities and weaknesses in software. So we have teams in Boston, we have a team in Belfast, we have a team in Oulu, Finland, and they're actually looking at how software is developed, how software is evolving from release to release in the aggregate, but also looking at things like the devices that we use every day. And so it's not uncommon for us to have a CVE disclosure. We've been averaging about a dozen or so a year over the last several years, just organically as we decide that we're going to take a look at something. It's not uncommon for us to go and take a look at, say, Wi-Fi access points or routers or things of that nature, because they've been relatively straightforward things to test for. Part of the work actually ends up coming out of our protocol fuzzing team, as they go and say, well, we've implemented a new technique to go and do this. Let's go buy as many devices as we possibly can and use that as our test set. And we will assume that those devices are doing the right thing. And if something bad happens, now we'll go deep into, well, was it us that created the problem? Was it the system wasn't properly tested? And that actually is a perfect example of how the shifting left, there's something to the left of the developer, and that's the piece of hardware. And so if the developer isn't properly interacting with that piece of hardware, well, now you start to get into where a particular choice of processor or memory configuration or support device might actually impact the success of the device. So we go all the way from that end of left all the way through into the production realm.
Yeah, I think you're getting into so I came from Ixia, now Keysight, and we did IP test and measure, and protocol fuzzing was one of the key features that we would introduce. I find it's a very low cost and efficient way to find vulnerabilities, and that gets us into another side. So we talked a little bit about application security testing, and you're in all of the spaces at depth, but you also do a lot of other specific complicated testing features and capabilities like DefenseX with your fuzzing, API security, IAC testing. You what am I missing? And then
container security,
container security
reviews. We could go on.
Orchestration, correlation. Can you?
Yeah, it's pretty complete, pretty comprehensive. I would say. Maybe it's where does one really begin with the program? Assuming some folks have some elements of AppSec testing in their organization. How does this all come together? What's a suggested path, Tim, for an organization to really continuously evolve with everything out there?
So I kind of look at three possible starting points, and it really depends on what the individual customer has already. So I'll start with a more services focused scenario. So let's say that there's a new CISO comes in, new VP of engineering, new CTO, new CIO, and they kind of want to get at least an understanding of what the current development practices are and where the risks are. We have a service called a BSIM, which stands for Build Security and Maturity Model. And that's an assessment that goes in and actually tries to figure out what's really happening. So if you go talk to the engineers, you'll get one answer. If you go talk to the development leads, you'll get a different answer. If you go talk to the executives, you'll get yet a third answer. So we take a very data science approach to going and doing that assessment, and out pops a report that says, you're really good in these areas. You got good foundational strength. You're kind of weak over in these areas. And for some reason, you're really advanced in this, but you don't have all the foundational stuff. So you probably want to go and focus in on that. That then is something that we can go and compare to other companies that have had a BSIM done and say, well, this is where your strengths are relative to your industry peers. This is where your strengths are relative to the universe of BSIM participants. And from there, start to actually say, how am I going to allocate budget? So you get out of the business of, hey, I've got the proverbial $1 million. I'm going to give 10%, 10%, 10% to all of the things. And oh, by the way, here's a carve out for all the license renewals that I need for my WAF and my edge protection and so forth. You get out of that by knowing exactly what the roadmap is and what the blueprint is. So that's one scenario. The next scenario is an organization that is got a little bit of AppSec, and they're trying to become a little bit more efficient in how they use things. For me, the starting point there is actually something like a Seeker IAST with the SCA option on it. So it becomes a combined tool that can be put in place in parallel to all of the testing that's going on. So it becomes a very lightweight way of identifying what issues might be there at runtime. And because it's a runtime thing, it can go talk about data flows and have verification of elements that are at risk and types of techniques where things have gone south. So it becomes very consumable by a development team. And then the last one is for those organizations that have a more mature environment, but they're kind of struggling with the how do I bring it all together? I've got a testing solution from each of these individual vendors. We have a solution called CodeDX, which lives in the application security and orchestration correlation space. Try saying that 5 times fast. But that ends up being the how do I actually determine which issues are correlated to which other issues? How do I actually understand from a security perspective what my true source of truth is? How do I actually have a system of record showing the types of testing, whether they're manual testing, so the periodic pen tests that you might need to do for regulatory requirements, how do they correlate with the development releases that might have a 2-week cadence to them? Are we getting better? Are we getting worse? And bringing that all together in a single pane of glass, independent of who the vendors are. So one of the nice things about our portfolio is we can slot people solutions in to fill gaps, or we can bridge across the solutions and bring their data into a more holistic view of the world that people can just kind of run with. So that ends up being 3 possible scenarios for organizations depending on where they are.
Truly comprehensive indeed.
So I started looking at BSIM, and is BSIM inclusive? Because you've got black duck audits, you've got threat and risk assessments you can do, you've got AppSec strategy, program strategies you can implement. Is BSIM kind of an umbrella that has all of those pieces in it, or is that a very specific implementation that people would come to you for?
It's a specific implementation that people will come to us for to kind of get a lay of the land. Okay. So it'll say things like, here's where you are in the maturity curve for configuration management. Here's where you are in a maturity curve for secure development environment, for attack and threat models and so forth. So there are multiple axes that are part of the model. And then typically what ends up happening is there's going to be some level of deficiency that's a focal point for the customer. And then they'll say, so what do we need to do to get past this point? That might be that we're going to bring in a maturity action plan. That might mean that we start to say, let's talk about architecture reviews or threat models or individual bespoke security tests. The black duck audits, they live a little bit outside of that whole space, mostly because they're typically used whenever there's an M&A transaction. So company A wants to buy company B. One of the two will say, we need to have a black duck audit done, and we need it done on Tuesday. Can you get somebody here? Here are the assets, and we need a report back. And then we do all the reports, sit down with their legal counsel and explain the data. And then whatever happens to the transactions, what happens to the transaction. We're on the due diligence side of the equation, not the actual, hey, go buy this side of the equation.
Yeah, no, that's fair. Okay, so now if we come back to, you talked about some entry points, which are important. Now we've got obviously customers that have various products, various workflows, et cetera. Is it fair to say that some of that selling motion, let's say, or go-to-market is, hey, it really doesn't matter what you have. One of the first things we can talk about is something like CodeDX. It can prioritize your vulnerabilities. It can integrate all of these other products that you may have across any of the AST space. Is that a logical place to start for folks, and then maybe get into IO, so intelligent orchestration, where we can start really integrating our workflows more intelligently, and then you start to talk about individual AST elements? Is that kind of a popular way for you to insert into a new customer that has programs and products in place already?
It definitely is. That's a perfectly rational approach. I would put that in parallel with the BSIM, because I like to go in and say, well, I don't know what I don't know, so where can we go? But it really is customer dependent. One of the nice things about the breadth of our portfolio is we're not forced to try and sell one thing. So if somebody comes to us and says, gee whiz, but I'm not happy with my existing SCA solution, you guys got this Black Duck thing, talk to me about Black Duck. We can happily go there, and we can happily cover specific scenarios where they might be perfectly content with their SCA solution for 90% of what they're doing, but they need to go and look at, say, binaries, and their existing SCA solution just doesn't do that. So, hey, take our binary analysis and run with that. So we've got a lot of flexibility where we don't actually have to push the wet noodle. We can go and have a conversation about what's the outcome that you want, what's your target, and how can we help you get there in the most efficient way possible. And that might be something like an intelligent orchestration, looking at all of the commit activity and recommending a specific type of test be performed in a security pipeline because of the fact that, for example, the code that changed actually touched PII, or would be subject to a regulatory audit in terms of its functionality. So we can get into that level of detail if we need to, but we're not compelled to go down any immediate path. We'd like to have that more trusted advisor type conversation.
Yeah. Hey, and finally, just curious, just going back to what we were talking about a little bit earlier, does Synopsys have any official involvement with more regulatory aspects? So when we were talking about the executive order from Biden, or when we're talking about the FTC's involvement in SCA in general, do you have influence over that? Or are you formalizing any programs that are coming out of that? Do you keep track of some of those advancements and government policies, et cetera, and start changing behaviors as a result? Is there an official kind of presence with Synopsys in kind of these germane topics?
There absolutely is, and there has been for quite some time. From a variety of regulatory perspectives, we're a key participant in a number of automotive standards groups, a number of open source standards groups. But if we look specifically at things related to the executive order, we've got several people on staff who are former Homeland Security people. We've got people who are have done DARPA work before. We've got people who are trying to influence the way that NIST is evolving its guidelines. So we've been producing policy papers and working workshops and so forth over the course of the last year. That's actually something that my team's been directly involved in. It's not just a case of, oh, executive order equates to SBOM. We're well beyond that. Some customers might be in that point of, okay, so I need to at least tick that box. But we're in the, well, what does it mean to have a truly secure development environment? What does it mean to go and have something that will have indications of compromise from the code itself? What does it mean to have something that is truly policy as code and have release gates that are defined around that, and have all of the various bits that you would see coming out of that executive order? And as it happens, yesterday, NIST just dropped a new lovely 326-page PDF update that we're going to have to go and digest. But we're directly involved in a lot of those kinds of things from a guidance perspective, from a policy positioning perspective as well.
All right, and so one more, if I may. So Tim, just given your position, going back to the OSRA report, to me there was some pretty alarming stats. But on the same token, like it looked like vulnerabilities has actually come down, especially for more critical vulnerabilities. It looks like some industries are more affected by some of these stats as well. When you look at, there was probably nothing that surprised you, right? You're obviously involved with this report. You're feeding all the research. What area though concerns you the most that you're seeing in terms of trend across the SCA space or the open source space?
There's one really big thing. And this is unfortunately an alarming thing. So we saw, I'm going to go with 8 off the top of my head, vulnerabilities that have been present at either a high level or an increasing level for 3 or more years. So we're just, people are not patching them for whatever reason. And when you look at what those things do, they're all living in the realm of data sanitization. So bad data in, assuming library is going to go and correct it for you and guess the right data type. And those are things where there's remote code execution associated with getting it wrong. The fixes are well-known fixes. And even if there's not a desire to patch that particular component, the solution from a code perspective is actually pretty straightforward too. Use explicit JSON schemas, for example. Don't let the libraries guess what your data types are. Don't let the libraries guess what your prototypes might be. And so it's those class of issues where they're not necessarily decisions that the individual developers are making. It's somewhere down deep inside some library someplace. They have some serious ramifications in terms of the potential vulnerability-ness, that's a word, of the actual code being produced. And it's not something that is going to be easily mitigated at the edge, which means that the ops teams aren't necessarily going to know how to contend with this. And it effectively, because it's not being patched, is a little bit of a blind spot to those organizations. And the fact that we're seeing them year over year, that's a long tail problem. For me, it harkens back to how long it took us to stop seeing Heartbleed, which was only 3 years ago that we stopped seeing Heartbleed.
Yeah. So Tim, that seems to be a call to action for many organizations to really take a serious look. But assuming different organizations have different maturity, what would be your suggested call to action at this point? Given obviously Synopsys has a complete portfolio we just went over, where should they really just start if they haven't already and take this more seriously?
So the biggest thing that I always recommend from an open source perspective, and it's like put all the stats off to the side, put people doing better, people doing worse. Open source is an opportunity to guide your own future. And there are quite literally hundreds of open source components that are in any given application. Some are more important than others. For those components that are critical to an organization's success, they need to first identify them. That's an SCA problem. But then they need to allocate some humans' time to go and engage with that project. Understand how it's developing, how it's evolving, how it communicates its updates, how things operate within that community. Doing so has a ton of benefits, both from giving an employee an opportunity to see how different processes work and bring that knowledge in. We saw a lot of benefit from people who are engaged in open source activities being more productive during the COVID remote work scenario because they had already learned how to work with a distributed team. They weren't suddenly saying, hey, my 20 peers that are inside this office were now remote. We need to figure this out. They already had that muscle memory created. All the way through to being able to say this feature is going to negatively impact our operations. So we need to either steer the feature this way or address it before the update comes along, before that release comes along, so that we have control of our own future. And so that gets back to the question you asked earlier about, well, what happens if the code is old and orphaned? And I said, well, I guess now you own it. This is one way of actually getting into the ability to understand what you own before you're actually forced to own it.
Yeah, from a philosophical perspective, I'm just curious your take on this. It seems like we don't have a ton of security engineers present. It seems like the developers have an incredible amount of pressure to just get products to market. How do we get the right attention that you're just describing, practically speaking, in an org? Where do you start, or where do you see that going maybe in terms of relationship? Because it feels like everybody is underwater and they're trying to prioritize. But some of these things, as you said, are long tails. What are some of your thoughts just on that dynamic in general?
So one of the big things that I talk about from just a process efficiency perspective is being able to go and adopt a philosophy of continuous improvement, but one based around the way that people tend to construct sprints. So every time that there's a new tool that's brought into an organization, new security tool, you can be guaranteed of two things. First, it's going to find a lot of stuff. Second, that people are going to go and complain that it found a lot of stuff and they don't know where to start. And the easy way around that is to say, I know that I'm going to find a lot of stuff. And some of it might be real and some of it might not be real. It doesn't matter. There's a lot of stuff. But if I now categorize each of those sets of findings into a CWE, I can now map that back to what the impact is to the business. So as a security person, I can do that mapping. Then I can sit down with whoever the product owner is and have a discussion around the impact of those things and start to construct a sprint. So as an example, let's say that there was 1,000 findings and 27 of them were SQL injection. The first thing that I would go and do is say, well, we can't possibly address all 27 SQL injection issues in a single sprint. That would be disruptive to feature flow. But why don't we do something where we tackle 3 or 4 every single sprint until we burn that down? We're not going to worry about the rest of it. It's a known state. Yes, we don't like it, but it's a known state. And then I can put in place a policy that says that 27, that's the magic number. Until we get to the sprint where we're chopping this down, there will always be 27 SQL injection issues. There will never be 28. There will never be 26, always 27. And that 26 becomes really important because if somebody's accidentally fixed something, that's a problem just as much as somebody accidentally created an additional issue because you didn't know. If you knew you were targeting it, you knew that was part of it, that's fine. But the release gate should be, if it's not 27, then we're having a conversation. We're going to figure out what just happened. And so that allows you to chip away at these things. And it's more of a continuous improvement paradigm. And it might be that because of the way that individual teams have structured things, some of the issues might reside in a different team. So for example, if you're building a containerized application, you might have another team that is worrying about hardening the base image. And if they have a process where they can go and minimize the attack surface, but you don't need to worry about it, what that attack surface actually looks like, you can now do a little bit of a divide and conquer.
Great. Tim, we've taken up a lot of your time today. We want to thank you for spending this time with us and being very informative to our community of listeners. Again, thank you very much.
I'll just add that every report we talked about, the OSRA, the BSIM, the Gartner report, if you go to Synopsys, it's all available. I encourage everybody to take a look. It's deep, it's informative, and somewhat shocking, at least for me. But we appreciate everything you're producing at the Research Center and, of course, Synopsys for the products. We appreciate it, Tim. Thank you.
Yeah, and for our listener base, if you have questions, please let us know. Darren and I are available, and of course, we'll weave in the right resources from Synopsys. So thank you, everyone, for listening.
Thanks, Tim.